So we're going to talk a little bit here about similar and congruent circles. This is section 10.2 if you're looking online on Big Ideas or if you're using your journal notebook at all. So we're going to talk about those congruent circles theorem, the congruent central angles theorem, and the similar circles theorem. So the first one states, two circles are congruent if and only if they have the same radius. Okay, so if two circles have the same radius, then those circles are in fact congruent. Okay. Then we have what's called the congruent central angles theorem. So if we're on the same circle, or if we're in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So here we're on the same circle. We have a pair of congruent angles. We know these angles here are congruent because they're vertical angles. So because angle CAB is congruent to angle DAE, we can say that arc BC is congruent to arc DE. So going back over here real quick to the congruent circles theorem, we can say that circle A is congruent to circle B because segment AC is congruent to segment BD, and those are both a radius or radii.
What is that
It means circle. It means circle A. That's our notation for circle.
What is it called?
Circle A.
That's what it's called? Little thing?
Circle A. Yes. Circle A is congruent to circle B. So let's go ahead and take a look at these two theorems on the inside. And these segments did not get highlighted, so let's go ahead and highlight. It says, tell whether the highlighted arcs are congruent and explain why or why not. So in example A, we're talking about arc CD and arc EF. And we want to determine if those arcs are congruent. So the first question is, are they on the same circle? Yes, so they're on the same circle, so that's good. The angles, the endpoints of those arcs are from a central angle, right? Are those central angles congruent? Yes, right? So, because the arcs are on the same circle, and angle CBD is congruent to angle FBE, we can say that arc CD is congruent to arc EF. Example B, the arcs that we're going to highlight are RS and TU. Are those arcs congruent? No, why not?
They're not on the same circle.
They're not on the same circle, okay? We're on two different circles. And are the radii of those circles congruent?
No.
No, so therefore, the circles are not congruent. So therefore, those arcs cannot be congruent. So we'll say no because they are on different circles whose radii are not congruent. And then part C, are arcs UV and YZ, are those congruent? Those congruent? Yes, why? Well, their angles are both 95 degrees. However, look back at part B, problem B. They had the same central angle of 90 degrees, but the radii here were different. So not only are those central angles the same, we also need to show that the radii are congruent. Are the radii congruent here? How do we know? Those little bars there, okay? So even though we're on two different circles, we're able to say that those two circles are congruent because their radii are congruent. So we can say that circle T is congruent to circle X because TV is congruent to XZ. Therefore, we can say arc UV is congruent to arc YZ because their central angles are congruent. All right, then the last part goes back to the front where it says similar circles theorem. All circles are similar. Okay? They all have the same angle around, right? They're all 360 degrees. Their scale factor would just be the ratio of their radii. On the inside here is just the proof for that. We're not going to work through that proof, but that's just the reason why circles are in fact similar. Okay. Any questions? All right, so if you